right, now we're going to do pages 335, 336. So they give you an example of the probability model again. It just talks about how they're going to be chosen at random in a drawing, and here's the outcome and the frequency. Again, it's out of 24 total. So you know that Kira is most likely to be predicted because she's got 9 out of 24. So what is the sample space of this experiment? So as you're going through with the sample space, you're talking about who are they talking about. So the sample space includes Dave, Kira, and Rachel. Okay, they are the sample space right here. Are the sample space. Why is it important that 3 sections of the spinner be the same size? It does say 3 equal sections. The problem says it is equally likely and splits into 3 equal sections. They all have this equal chance of being chosen, so that's why you have to make sure that your spinner is equal. All right. What is the theoretical probability? So we've always been talking about experimental probability, so that's like they actually performed the experiment. Now the experiment's not actually being performed, we're just guessing. Okay, based off of this, what is the theoretical probability that here will be chosen? Is it equal to the experimental probability? So the theoretical probability that she'll be chosen is that she's 1 out of 3. Okay, is theoretical. But as we saw, she got 9 out of 24. 9 out of 24 is the experimental. Okay, they are not even because 1/3, if you make it into 24ths, that's times 8. So this would be like 8 24ths is the theoretical, and 9 24ths was the experimental. So they are not equal. Okay, will the theoretical probability always be different from the experimental? No, the theoretical is telling you what they think is going to happen, and a lot of times that is what happens. So no, they can be the same. It depends on the experiment, right? So when the experiment actually happens, it depends on the experiment results. Okay, it depends on when they actually do the experiment. Are they going to match what you theoretically, you use your educated guess? Is your educated guess going to be true or not? All right, 336. A computer game has 2 equally likely paths that a player can take. Path A is favorable, right? Is most likely to happen. And path B is unfavorable. You toss a coin. Heads is path A. Tails is path B. The results are in the tally chart. What is the experimental probability that the path taken is path A? So experimental is looking at, hey, what did you actually get? So we got 5, 10, 11, 12, 13, 14. So we got 14 out of 14, and then 10, 24. 14 out of 24 is experimental. What is the theoretical probability of path A? Well, it's heads or tails. Heads or tails is always exactly half. So half is the theoretical probability. Why are they different? They're different because the experiment is chance. Theoretical is knowledge-based. Right? So theoretical, you're looking at, oh, I know heads or tails is always a 50-50 chance based on knowledge that you have. The experiment is just you actually try it, and it's actually usually based on chance, okay? So now we're referring back to 5. Suppose they went from 24 to 200. So they went from 24 to 200. How would this affect the experimental probability that is taken to path A? So if you have path A, and as the trials increase, Okay, so that's difficult to know, but basically as the trials increase, what happens is the probability goes closer to theoretical. Okay, it becomes closer to what the path originally was. So the experimental probability gets closer to the theoretical probability. Okay, a survey shows that a certain intersection 50% goes straight. Okay, straight 50%, left 25%, right 25%. Describe a model for finding the probability that a random car will go straight ahead. So it looks like we're doing theoretical, right? It's a theoretical idea. So if we had the equally likely outcome. So are they going to go straight left or right? Well, luckily this is 100% of the options. So a model for that, I could use a spinner. Where half is straight, 1/4 is left, and 1/4 is right. Then I could spin to see results. Right? If you were to spin it, depending on how many times you'd spin, the likely probability is straight because that has the highest probability. Left and right are as likely as not, because of the smaller probability. Okay, this is a good predictor, okay? Gotta make sure we answer all the questions. So this is our model that we described, and we feel like it would be a good predictor. There's page 335 to 336.